the new chapter today. For grade 11, we'll be starting with basic concepts of chemistry. Since it's a new chapter and it's a new academic year, here are a few things we need to consider. There's a huge gap as we are coming from grade 10 to grade 11, and there are many things to consider before we actually jump into the chapter. So we will be going through some basic things, some very rudimentary things which might be extremely nominal, but at the exact point of time may be difficult for someone to understand. So we will be looking at all of these things all together. And wherever you are having difficulties, please do share your concerns or your doubts so we can take up those and discuss them right away. With that being said, let's start with the chapter. So we'll start with a few physical quantities. Now, here are a few things, here are a few pointers that I want to add here before I start jumping into different things. See, when we are trying to measure something, when we are trying to make sure that, let's say this is a physical quantity which I want to measure, what's the best way to measure it? And what's the most fundamental way to measure that? So for us, and it's not just for chemistry, it is for all of chemistry, physics. We have a few quantities. There are exact 7 physical quantities which we actually measure, and these are length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminosity. Why do I talk about these and not the others? Like, for example, there is force as well, power is there. Let's say if you're talking about charge, that is there, and so on and so forth. Why do we not talk about these? The reason is because all of these values are fundamental values. As in, if I talk about length, then length is the most fundamental way of measuring distance. So let's say if the measuring distance is done in centimeters, meters, kilometers, and so on and so forth, it is done in terms of length only. There is no other, fundamental unit which defines this. Same goes for mass, which measures a kilogram. Or when you talk about time, it is measured in seconds or hour. There is no other unit that you would use in terms of that. So these are few fundamental terminologies which we need to consider. There is one more fundamental value which we will be utilizing in this chapter, that is the amount of substance. This is extremely important. Now, when we say amount of anything, we tend to, rhetorically say this, that amount of something usually means in grams or in kilograms, or maybe it's just a certain terminology. But in chemistry, amount of substance simply means a mole of a substance or certain number of moles of a substance here. All right, so we'll be utilizing that in this class. Now, as much as these particular units are used, you also need to consider that, likewise I said, for length, it can be measured in meters, centimeters, kilometers, decimeter, picometer, so on and so forth. There are many, many different terms for which you can see the values here. So for example, if I talk about the zepto meter, it is 10 to the power minus 21 meters, and that is where the conversion comes in picture. We have to understand very carefully that conversion is an inherent property of any particular topic, especially for this one, and therefore it becomes extremely important for any question that you go for. So even for a very specific or very basic question, you must know a certain number of conversions, because that becomes extremely difficult as you move forward. So let's say if I have been given 28.7 picometers, I need to convert this into its basic units. Now, how do I know what is the basic units? And this is where the table that we have seen previously comes in picture. Now, the basic unit here refers to the SI unit, and therefore for length, it is always given in meters. So what I want to do is I want to convert this value into its basic SI unit. So for 28.7 picometers, I can rewrite this as, if I were to see picometer, picometer is exactly 10 to the power minus 12 meters. All right. So I can write this value as 28.7 times 10 to the power minus 12 meters. Okay. Here's another thing I'd like to add. Usually when we write a value, we write it in something known as a scientific notation, which simply states that there is one non-zero digit which comes before a decimal place. So therefore, the value that must be written should have been written as 2.87 times 10 to the power minus, this would become minus 11 meters. Okay. In the same way, we can do for the others as well. I highly suggest that you guys go through the questions. And if you have any queries or questions, you can come back to me. Now, this is just one type of conversion that you have seen here. The different type of conversions can happen not just in mass. It can happen in any fundamental unit. For example, it can happen in temperature. It can happen in, let's say, if it can happen in mass, right? It can happen in luminosity and so on and so forth, right? So I want to bring forth a certain set of conversions which are always there for us to use in chemistry. All right. I am not talking about physics, but for chemistry, this is something that we use. For example, if we talk about mass, mass can be defined in terms of kilograms. It can be defined in terms of ton. It can be defined in terms of gram. But usually the conversion factor is extremely important for us. And that is what I'm trying to point out here. So for example, 1 kg is equal to how many grams? As we know, it is 1000 grams. But let's try to depicted in a certain way, which is written in a scientific notation. As I said previously, anything that must be written should be written in such a way that you write only one non-zero digit before the decimal place. So therefore, I can write 1000 as, I'm writing it below, as 1.0 times 10 to the power minus 10 to the power plus 3. All right. So I can write it as 10 to the power 3, but I choose to write it in terms of scientific notation. Similarly, and I'm not going to do every single one. Let's leave it for after a few minutes, we can finish it individually. Let's talk about length. Let's say if I'm writing in terms of angstrom. So here it is written 1 angstrom is equal to how many centimeters? So if you go back to the table, you can see where is it written? So it's not written here, but I'll just refer to it. 1 angstrom is actually equal to 10 to the power minus 10 meters. So by that logic, if we apply it in terms of centimeter, it will be written as 1.0 times 10 to the power minus 9 centimeter. Okay. You can apply the same logic to volume as well. For example, 1 liter is equal to how many cc's? Now here's a very important and very I mean, it might seem very rudimentary and it might seem very uncharacteristic, but certain times many students do not know what is a cc and what is a centimeter cube and what is the difference between them. To clear it off, 1 cc or 1 cubic centimeter is equal to 1 centimeter cube, which is equal to 1 ml. I think that clears that off, right? So by that logic, 1 liter should be equal to 1000 cc, and by that logic, I can write it as 1.0 times 10 to the power 3 cc in this case. All right. Okay. So we can do others as well, but I want to take a specific example of density and then we can move forward. In case of density, it's written that the conversion factor must be written for kilogram per meter cube to gram per centimeter cube. Now, how do I know that it is kilogram per meter cube? So the thing is that it is written in terms of kilogram times meter minus 3 to the power minus 3, right? So if I were to, in very rudimentary terms, and I know many of you guys are already aware that let's say if I write something 1 by x, right? So if I do not mention anything that it is, then it is already assumed that this is x to the power 1. But what if I want to bring this x on the numerator side? So then it becomes x to the power minus 1. All right. So same goes here as well. When I'm writing kilogram per meter cube, I'm simply writing as 1 kilogram upon 1 meter cube. Okay. That's the best way to understand it. That's the most simplified way to understand it. All right. What if it was written 10 kilograms? So I can simply remove the 1 and put 10 kg per 1 meter cube. Okay. All right. So I think that is clear to all. Anyways, coming back to this. So how do I convert it into gram per centimeter cube, right? So if I were to rewrite this in terms of gram, I can convert each of them individually and then come up with a solution at the end of it. So I can write it as 1 times 10 to the power 3. Okay. And since we are converting meter cube into centimeter cube, let's first of all understand what is the difference here. So 1 meter is equal to 10 to the power 2 centimeter, right? So if I cube a meter, then I have to cube the centimeter as well. Therefore, 10 to the power 2 becomes 10 to the power 6. So therefore, I can write it as 1.0 times 10 to the power 6. And I can write the units as well, gram upon centimeter cube. Okay, solve them. So this will become 10 to the power 3, 10 to the power 3 minus 10 to the power 6. Okay, minus 6. So I can rewrite it as 10 to the power 3 minus 6, right? Into gram upon centimeter cube. All right. So therefore, I can rewrite this as 10 to the power 1.0 times 10 to the power minus 3. All right. Okay. So this is something that I wanted to, reiterate and share it with you. I have a few questions here. If you want, please have a look at it. Let's talk about the scientific figures. Okay. Significant figures. Sorry. So in case of significant figures, you have to understand there are many things to consider, but it's not the most difficult thing. The difficult part comes in remembering. All right. So let's understand it pretty quickly here. Here's a particular value which is given to us. As you can see that there are zeros which are before a non-zero digit, which is if I were to highlight it, it is 5, right? So before 5 there are zeros. After 5 there are zeros, and then there are zeros which are after the actual non-zero digit. Okay. So there is. Let me reiterate it. There are zeros which are before the non-zero digit, which are in between. I should have said it before, in between 5 and 8, and then there is a zero after. So they are given different ways. For example, the zeros which are before the non-zero digit are referred to as insignificant figures. Okay, so we will discuss about it later on exactly what these are. Then there is a zero which is in the middle, right? So these zeros which are in the middle of two non-zero digits are referred to as significant. Okay, again, we'll discuss what this means in a minute. Then there are trailing zeros, okay, which are after a non-zero digit, right? These are also referred to as significant figures. Again, that depends on the value that you're writing. Not every single time it may be the same. Okay. What about non-zero digits? Non-zero digits are also referred to as significant. What this means is if you are considering a particular, number of significant figures, you must count them. And to count them, you must consider them to be significant in nature. Okay. So let's say if I'm counting how many significant figures are there, I'm counting these digits in this case. All right. Whether it be 0, whether it be 5, whether it be 8, or so on and so forth. I must count them as significant or insignificant. So for a number to be insignificant means that I have to simply ignore it. For numbers which are significant, I have to count them, and I have to add them up to give me the number of significant figures. So for in this case, if I consider 50830, it has total of 5 significant figures. Is that clear? Okay, it has total of 5 significant figures. As I mentioned earlier on, all these 5 digits are considered as significant because they are positioned in a specific way. As far as the non-zero digits are considered, they are always considered as significant. Okay. For zeros, you must understand zeros before a non-zero digit, irrespective of the decimal place, are considered as insignificant. Zeros in the middle and at the end are considered as significant here. All right. This brings us to the addition, multiplication, subtraction, division part. So we can utilize this time to understand that pretty quickly. As far as addition and subtraction rules are considered for significant figures, we must understand that we cannot just write the answer in the way that we want to mention it. We must adhere to certain rules in order to write the answer. For example, the number of significant figures that the answer must carry should have the same number of decimal as the number of the fewest decimal places. So what does this mean? So if you look at the two values, 4.4981, and then look at the next one, which is 1.26. So in this case, if you consider both of these values, both of them have different number of decimal places. If you consider the first one, it has 4 decimal places, being the decimal digits here. In the second case, there are only 2 decimal places here. So subtracting the two, the answer that you will get, obviously you will get 4 decimal digits, but you will round the answer off, okay? Or you can simply consider the answer with only 2 decimal places when you're doing addition or subtract. All right. So you have to consider that. In terms of multiplication and division, you have to do slightly differently. You cannot consider the number of least number of decimal places when you consider multiple values that are added or subtracted. Here you need to consider slightly differently. So the answer that you will get, or the product that you will get, whether it is from multiplication or division, should have the same number of significant figures as the fewest, as the starting value, which has the fewest significant figures. So considering these two values, if you consider 8.65 and then multiply it by 2.053, considering that 8.65 has one less of of a significant figure, that is 3 instead of 4, the final answer that you will guess must also have a 3 significant figures, and this is irrespective of the decimal place. You must consider that. Similarly, look at the one below. You can see that the numerator value has 4 significant figures and the denominator has 3 significant figures. So the final answer here has 3 significant figures accordingly. All right. So this is all about significant figures. The final thing that I want to talk and I would like to disperse here are the implications of what we are actually doing, right? So many a times I've seen that in terms of NCERT, or let's say if you're going for some sort of competition, that the sort of question that you will get has certain conditions written on it. The most commonly written conditions are in terms of STP, right? This usually means standard temperature pressure, and it has some traces in the previous years as well. It's not like that it has not been written. It's just that it has never been described. So what I'm trying to suggest here is when you are, trying to do a question, there are conditions, a trinity of conditions which are written, which are temperature, pressure, and volume. But my suggestion would be is that when you are writing an answer for yourself, make sure that you have a table like this written, or you have it sticking on your wall, so that you can actually refer to these values as you're moving forward. So these are some few tips and tricks which I wanted to share with you as we start this academic year. And wherever you're facing issues, have a look at it and please do let me know so that we can move forward and discuss these. Okay. All right. Thank you so much. Take care. Bye.